Hello and welcome to this presentation on digital fabrication in the museum space. My name is Adam Bradshaw. I am an exhibit specialist at the Smithsonian Institution National Air and Space Museum. Here's my contact information in case anybody needs it. So I'm going to be talking about digital fabrication, and for the purpose of this presentation, I've identified three key aspects that I want to discuss. Digital fabrication as a system that uses gathered data for analysis, design, and fabrication. As a design workflow that incorporates CAD and CAM towards production. And as a means of rapid prototyping. I'm going to show examples of our data gathering process, our design workflow, and our production output. In terms of data, we've used medical imaging to analyze object interiors that were previously inaccessible. We've also incorporated 3D scanning into our object handling and mount making workflow. Now let's look at ways in which we've used medical imaging for creating a new mannequin system. This is a CT scan that was taken of a spacesuit glove. We used a DICOM viewer to analyze the data set and determine the best areas to create a mounting mechanism that would allow the glove to be displayed as though it were attached to its suit. Within the DICOM viewing software, we created 3D representations of the data set and then isolated the relevant areas for development of the mount. From this high contrast model, we could then examine the glove's interior and determine fixture surfaces the mount could attach to. We also use CT scanning to analyze the interior voids of the spacesuit's boots. Because of the suit's construction, these areas had previously been inaccessible for development of proper foot support. Using the tools within the DICOM viewer, we could create cross-section views that showed us the boot's interiors and the obstructions we would need to work around. Now let's look at 3D scanning examples. Here we have a scan being taken of an existing mannequin that was no longer going to be used. We scan the mannequin for size and proportion reference in creating a new display form. We are currently using a 3D scanner that captures both geometry and color, allowing us to create high-quality scan models. Within the scanner software, multiple scans can be combined together to create a 3D model. This allows us to create 3D models of objects on a variety of different scales. Now let's take a look at the design process, including working with STL models and 3D CAD software. If we go back to our glove example, we can begin the process of exporting the 3D model as an STL file. From the DICOM viewer, we can create a surface model of the isolated parts of the glove. We can also see how our surface model compares to the original data set. The model looks good and is now ready for export. We've brought our model into a mesh editing software. As you can see from the example, our 3D model is made up of millions of small triangles. Not all the information is needed, so we're going to isolate and trim the parts that are unnecessary. From there, our model can be brought into a CAD program, and design ideas can be evaluated against the scan data. We also use this workflow for developing a foot support for the boots. We knew that space was limited, so we wanted to develop a mannequin foot that would turn and pivot as it reached the bottom of the boot. Now let's look at how we create 3D CAD models directly from scanned data. Here we are scanning an object to create a support mount for a new display. With the scan model in our CAD software, we can use the surface to create support brackets. In this example, the scan surface of a fender was used to sculpt an ethafoam support for it. Likewise, the surface of the shaving cream tube was scanned, and then a sheet metal forming block was machined to make the mount. Next, let's take a look at production. This includes subtractive manufacturing, or CNC, and additive manufacturing, or 3D printing. Going back to our previous example, the sheet metal support bracket that was designed was then flattened and turned into a shape that could be cut using a laser cutter. Additionally, we designed forming blocks that were then cut on a CNC router. Lastly, a 3D printed facsimile of the object was created so that the formed mount could be fit checked against it prior to fitting against the object. This workflow has been repeatedly used to limit the amount of direct contact needed with an object. FDM 3D printing has been used for creating object facsimiles to aid in the mount making process. It's also been used for creating tools, jigs, and fixtures. In areas where engineering tolerances are needed, we've relied on SLA 3D printing for creating complex prototypes. CNC production has been the cornerstone of much of the final products created through digital fabrication, allowing us to create complex shapes in a variety of different materials. As example, this mannequin system that was developed for the spacesuit project could not have been created without the use of CNC production. In summary, I'd like to go over some of the key aspects of digital fabrication and how it can benefit the museum world. First off, digital fabrication has the ability to handle complex and challenging mount situations. It also increases the speed of rapid prototyping. It is reliable and repeatable and allows for greater collaboration worldwide. Lastly, it is also scalable, meaning it can be used for one-off production all the way up to large-scale manufacturing. This concludes the presentation on digital fabrication in the museum space. I hope you have enjoyed it. Thank you to all the IMF organizers, staff, and volunteers that helped make this event possible.
Wow, fantastic presentation. Let's open it up for some question and answers. I know I have a few. Our Q&A facilitator is Lauren Osman.
Hi, Adam. Thank you.
Hey, Lauren.
Thank you so much. That was so interesting and a really beautiful presentation.
Thanks.
Enjoyed it. Thank you. So I'm just going to go straight to the Q&A chat, and I saw that you had answered something live, and so I'm just going to repeat it out loud so that everyone is on the same page. So the first question was this in-house or third-party CT scanning? You answered you use the CT scanner at the National Museum of Natural History. Yep. The second part of that question you didn't answer, though. I'm wondering, does it affect the budget?
It certainly could.
Yeah.
You know, in the past, I would have said if you're looking for a local CT scanner to be able to use for projects, consider contacting your local hospital or partnering with universities, particularly medical universities, that might have that technology in-house and be able to facilitate those requests. With everything going on right now, I'm not sure that that's probably as feasible as it had been in the past. I know that it's also a technology that's used a lot in large zoos. So it's used particularly for care and treatment of the different animals within the zoos. So that might be another avenue as well. But we are fortunate with the Smithsonian to have that technology in-house and to have that ability to cross-share technology between the different museums.
Great, thank you. And maybe I'll just kind of piggyback on that question. I'm just wondering about how user-friendly the software is, because I'm assuming like with the other SI unit that you worked with, they helped you with kind of the scanning and like the different kind of methods of data acquisition. But then at the end of the day, you're probably the one that's going to be manipulating the data, right?
Yeah, so the example of the glove, that was the raw DICOM data set coming into the program. So depending on how the data is scanned, you can wind up with a data set that's really easy to work with. And that screencast of me going through and creating the 3D model, that was, I believe, all in real time. So a lot of the software has become incredibly user-friendly. There are a lot of different DICOM viewers out there that are free, and they've become more and more simplified, I think, in a lot of ways, because they understand that it's not just being used for medical assessment and imaging anymore. It's being used by a bunch of different people for a lot of different things. So some of the software is pretty easy to use. There are a lot of really good videos on YouTube showing people doing similar things in their methodology of how they access the DICOM data set and then how they extract the information that they need for 3D printing or for CNC production.
Cool, thank you.
Yeah.
So our next question is from Evan, and they're asking, what is the handheld photogrammetry scanner called?
So the one that was in the example is the Artec Leo. We were fortunate to be able to write and receive a grant to purchase 2 new scanners this year, the Artec Leo and also the Artec Space Spider. The Leo has been a real game changer for us because of it being a handheld scanner, and it also captures both really good texture quality and geometry, but also the color and photographic quality. And it's been used a lot within, I'd say, probably the past 6 months for a variety of different projects. And it's allowed us to scan things kind of from, I'd say, like the microwave size up to the other day we did a Rolls-Royce jet engine. So you have a pretty wide range of what you can scan with that.
Very cool. Thank you. So our next question is from Nan. And I realized that a lot of the equipment that you're working with is through, or it was the CT scanner that was through Natural History.
Yes.
Okay, I'm just going to ask the question. So what are the costs for equipment and software? How long did it take for you to learn to use it?
So the cost can vary. There are certain scanners, not CT. CT scanners can be very, very expensive. And they also require a dedicated room space to be set up. They require shielding to be part of the room setup, and operation of them can be pretty taxing. But the handheld scanners, they range in price. There are some on the market now that are around 7,000 to 10,000. I know that the Artec scanners tend to be in the range of between 15 to about 25. There are some other units, there are some other units out there that could be upwards of 60 to 80,000. So there is quite a wide range. One of the things that's also developed now is there are more and more rental companies that will rent you the equipment and the software license to be able to process the scan data for whatever length of time that you need it for your project. So depending on where you live, there might be rental equipment available that might be a more cost-effective solution. In terms of learning the various different programs, it's kind of been a lifelong process for me. I didn't used to do much of anything with digital CAD. I didn't used to do much of anything computer-based. My background is in sculpture. I always thought that if you were spending your time on a computer, you were missing out on all the fun of making things with your hands. Mm-hmm. But it is a process. I've found for myself that when you learn 1 or 2 particular programs, the ability to learn other subsequent programs is much, much easier, because a lot of them all rely on the same methods and the same approaches to manipulating information and creating 3-dimensional forms. A lot of them are free. So many of the Autodesk programs are free or at little to no cost. There are, again, tons of YouTube videos. Most of the programs also have built-in tutorials, which are a really great way to get up and running with them. So I recommend if anybody has any questions about which programs were used for what, they can shoot me an email, and I'd be more than happy to walk them through what we use.
That's great. thank you. So our next question comes from Helene, who says, wow, amazing. When scanning soft, quote, objects like the glove or boot, how do you set them up so they don't slouch down? Do you use some kind of temporary mount?
Yeah, so with the glove, we actually used our typical glove mount display, which was a soft padded Ethafoam structure on a acrylic rod with an acrylic base plate, which is kind of the reason why in the DICOM viewer it showed up the way that it did, as almost like a translucent material because of the density quality of it. A lot of times when we're scanning things, we will create soft cradle mounts for the object to be in a particular position. So a lot of times that's using Ethafoam, or it's using Filara, or it's using polybatting to create a cradle that the object can be held in a particular orientation to help with the scan. A lot of times when you're scanning objects, if you can't get 360 around it, so if it's not something that can be suspended or that you can lift up very easily, you are going to wind up taking multiple different setups and then combining them all together in the scan software.
Great, thank you. And so Jonathan is wondering, if you've actually used 3D printing to make like real actual mounts, and if so, is the material conservation approved?
Unfortunately, none of the materials that we've tested so far have been conservation approved. There are some materials that are, for lack of a better term, less bad, but almost all of your FDM materials, which is the fused deposit material method, which is the cheapest 3D printing approach, and that's what we use for a lot of facsimiles. Almost all of them are thermal set plastics, and they're really not safe. The SLA printing, in which you have a liquid resin that's cured using a laser that has a particular wavelength to it, and then it also goes through a secondary curing process in a UV chamber. Those are less harmful, but they still long-term just are not safe for long-term display. Hopefully, eventually, there will become a 3D printed material that will have a conservation approval. It's just not something that I've come across yet, and we've tested a variety of different materials at this point. So we'll keep looking, and if there is one, then that certainly would be an option. At the moment, most of our 3D printing is to make either a facsimile that then we make the mount directly to, or it's to create a working prototype that then will become machined out of something like aluminum or brass or acrylic, or like those standard materials that we know have a conservation longevity on them.
Great, thank you. Fingers crossed.
Yeah, I mean, every day they're coming out with new materials, particularly in the SLA community. Every day it seems like they're coming out with something new. I just think there's probably going to have to be some sort of push for a material that would have more of a natural inert state.
Right. So our next question is coming from Kimberly, and she's wondering how often you use these sorts of like digital technologies and what the criteria is.
That's a great question. It's not something that we use in every instance. We certainly don't rely on it for things where a simpler, more straightforward approach to mount making would be the best approach. We use it in instances where we are dealing with an object that's particularly complicated, where we think the object is incredibly fragile and we want to limit the amount of handling that is needed. in order to complete the mount. We also use it in situations where we might have an object that we, for whatever reason, our timeline and our access to that object is so limited that we just would not have the standard amount of time to develop a mount and test fit a mount. So we will use scanning in that instance to help facilitate the absence of that object, particularly if something's going on loan or if something's going through a very long conservation treatment. Those are instances where we found 3D scanning and also the digital replication and digital mount making has become really useful. But it's a tool. It's a tool that we take out when it's the best tool for the job. So.
Great. And so you find that this means is actually faster than I guess more traditional forms of mount making, the time?
Yes and no.
Yeah. Okay.
It can be the length of time can be much longer than a traditional mount, or given the complexity of a particular object, it could very much shorten the time span. It's really about getting a sense of what sort of commitment you're making, either in terms of the amount of time to scan the object, the amount of time to clean up those scans, and then from that scan data, how quickly are you going to be able to get the best sense of what kind of output you're going to be looking for. Certainly if something's going to be machined on either a CNC or cut on either like a laser cutter or a water jet machine, starting with the scan information is going to shorten the time span between when you took that information and when you have physically something in your hand to work with. So.
Great. And so Earl has a question, and he says a couple of the most important aspects of objects when it comes to designing mounts is the object's weight and its center of balance.
Yep.
How are you compensating for not having this information while designing mounts?
So particularly with like airplane models, we will handle them to determine the CG on it. A lot of times, some of the stuff that we're scanning, there will be original hanging points that we can reference off of. We can also access a lot of the, I'm thinking particularly to like some of the NASA elements or some of the NASA developments. We can also access some of their original drawing sets, and then from there we can kind of guesstimate, I think, in a lot of instances. When we're dealing with aircraft elements that we just don't know, a lot of it's going to be factoring in the volume, which we can calculate from the scan, and then an overall sense of, is this made out of an aircraft aluminum? Is this made out of corten? Is this made out of sheet metal? Those sort of things come into play. But a lot of it's going to be sort of case by case. One of the things we can do with the CAD software is we can also begin to run structural analysis. So I'm not an engineer. I don't, my training is not in engineering. But when I do begin to design something that I know is going to be reviewed by an engineer, I usually err on the side of overbuilt is much better. So if we're looking at different safety factors, I'm almost always looking for like a safety factor of 10, which means the estimated weight of the object and the estimated load of the mount. It would take 10 times that to ever cause the mount to fail.
Great, thank you. And so we have a couple more questions. One is again from Kimberly, who's asking what the size limitations are for scanning. Or for, yeah.
So one of the things that's nice with the Artec Leo is that you can scan section by section, and as long as you have enough cross overlapping either geometry or color, you can then stitch those together in the software. So in the instance of the Rolls-Royce engine that we did a week or two ago, I want to say that's 25 or 30 feet long. But the scan section that we took was probably only about a 5 foot by 5 foot section at a time. And we just made sure that each 5 foot section had some sort of overlap with the next one, and then stitched them all together in the software. With some of the smaller scanners, you're looking at, a scan area that's maybe only 3 to 4 inches. Those are, particularly with like the Space Spider scanner that we have, that's a much more higher detail, higher resolution scanner. So those are instances where you wouldn't really want to try to tackle a very large object with that. You would want to focus on objects that could kind of fit within that 3 to 4 inch parameter. So they do make 3D scanners now that can do an entire room, like a very large room. So, size is quickly becoming no longer a limitation.
Yeah, I remember I was at the Natural History Museum in London, and they were scanning tiny, tiny, tiny insects, and then 3D printing them so they're much bigger.
That's great.
In the future. So yeah, it's a nice.
Oh, that's great.
So we have another question from Pierre-Luc, who's asking, does scanning affect light-sensitive objects?
I would, off the top of my head, I would say no, but you're definitely exposing it to a light source. So particularly with anything that's going to use a structured light mechanism for scanning, it's going to be strobing a particularly strong light source at whatever object you're trying to scan. So I would say if you're calculating the light exposure down to minutes of exposure for the lifespan of that object, it's definitely something you would have to factor in.
Great. And Pierre-Luc is following up. He says, did you try a Luxometer to measure it? Luxometer.
I've not. That is an interesting idea. I think I'll reach out to our conservation staff and see if we could measure the lux coming off of the various different scanners and get a sense. That's a great idea.
Great, thanks. All right, BJ, how are we for time?
Well, actually, we have a little bit more time for questions, a few more minutes. If there's anyone else has anything. Adam, this is fantastic. And I have to say that this is technology that here at the Getty, we've really started to embrace, and it pretty much has replaced the old methodology of taking paper templates and especially for our changing exhibits, for objects that we don't have access to until, just right before an installation. If we have an opportunity, we will try to get out and see those objects, scan them, and then be able to, as you're doing, print one-to-one replicas or parts or sections of the objects that we can work on directly as an intermediate step to be able to prefabricate things much more accurately. And it's really proven to be a successful method.
That's great to hear. I love knowing that there's a community that's growing around all of this, and that is embracing all this. It's definitely a new step for a lot of people.
I agree, and I think it's something that institutions should really start to be looking at and sharing information. Because it's changing a lot, and there's no sense in reinventing the wheel on a lot of this.
Oh, no, absolutely not. I mean, like I said, I learned so much of what I've been doing and what we've been doing. I've learned so much from kind of watching other people and sort of walking through their footsteps and figuring out, where their path is applicable to what, I'm trying to accomplish. So,
Exactly, exactly. And it's great to see you using the 3D modeling as well to work out your designs. I mean, I have to admit that's kind of I've become addicted to that as my workflow. And to try to think things through dimensionally, and to be able to see things at all different angles, and to be able to move parts and to see the interactions. It's really they've been a huge benefit.
yeah, it's been really helpful to us also along the development phase of a lot of different projects. So being able to bring people in from the design portion, or from the project management portion, or from the conservation portion, and sort of walk them through the physical 3D models that we're developing
Right.
regarding either their exhibit or their objects, and sort of explain to them the process that we're hoping to use. It's been really great in being able to give them a visual cue as to where we're going with things, as opposed to a lot of scratching things out on paper. So,
Right, exactly,
yeah.
exactly. No, it's a fantastic tool. I'm a huge proponent for it, and as as you mentioned, technology is changing all the time and
Yeah,
becoming more and more accessible.
yeah, it's becoming more and more accessible. It's becoming, the price point for a lot of this stuff is going down tremendously. I was just thinking the other day about some of the 3D printers from like the early 2000s, and they were really unreliable, or just really, really expensive, and unbelievably so. And now we're kind of at that same phase with 3D printing in metal, where a lot of them are not, there's not a readily available market solution just yet. But I would imagine in the next probably 5 to 10 years, we'll be seeing that becoming more and more ubiquitous. So,
Yeah, no, I totally agree.
yeah,
Yeah, it's an exciting time. I
yeah,
really,
yeah, it is.
I very much kind of geek out on it. I have to tell you that, I'm sorry, last thing was that I downloaded Armstrong's spacesuit scan.
Oh, cool, great.
It's really cool. If anyone has that opportunity to, it's worth checking that out. It's an amazing look at that
Yeah,
object.
yeah, that whole project was really great.
Very cool. Well, I think we're close to our time.
Okay.
But thank you, Adam. Again, it was really great to hear what you guys are doing and pushing it forward. It's fantastic.
Yeah.
Really appreciate all of that.
Well, thank you so much. This has been great.